a dream that lasts.
Welcome to the Startup Venture Lab podcast, the place where ambitious entrepreneurs turn ideas into profitable online businesses. Whether you're launching your first startup, scaling to six figures, or looking for game-changing growth hacks, you're in the right place. Join us as we break down proven strategies, expert insights, and real-world success stories so you can build, grow, and dominate in the new digital world. Ready to take action? Let's dive in with our host and tech entrepreneur, J. Todd Jennings. Over to you, JT.
Welcome to the Startup Venture Lab podcast series on the end of prompt guessing. This is episode 1 of 3 in this series. I am JT, and I am joined by Madison Paulson. This 3-part podcast series will help you learn how to fix unreliable AI results using simple and practical prompt strategies. It's designed for beginners and professionals who want to stop guessing, improve consistency, and get better outputs from the AI tools they are using. Okay, so get this, 40%. That's the hallucination rate for some AI systems in medical reference tasks. 40%. Imagine if your doctor got things wrong almost half the time.
Oh, wow, that's a terrifying statistic. And it really puts into perspective how much trust we're putting into these systems, sometimes without even realizing it.
Exactly. And that's what we're diving into today. Why AI can be so unreliable, how it's failing us in critical ways, and most importantly, what we can do to fix it. Because let's face it, we're all using AI in some form, but most of us are secretly drowning in what we're calling work slop.
Work slop is such a perfect term for it. It's that endless cycle of fixing, editing, and redoing the work that AI was supposed to handle for us. Instead of saving time, it feels like we're just shifting the burden.
Right? You go from doing the work yourself to grading the work of a machine. And let's be honest, correcting AI's mistakes can sometimes feel more exhausting than just doing the task from scratch.
And the stakes are so much higher than people realize. Sure, if you're brainstorming dinner ideas and the AI suggests something ridiculous, it's funny. But in professional settings, a mistake can be a massive liability.
That's exactly what happened in the 2024 Air Canada case. A passenger needed to book a last-minute bereavement flight, so he turned to Air Canada's chatbot for help. He asked about their refund policy, and the chatbot confidently gave him an answer.
But the problem was, the chatbot completely made it up. It told him to book a full-price ticket and claim a retroactive refund within 90 days. The only issue? That policy didn't exist.
Exactly. So he trusted the AI, booked the ticket, and when he tried to claim the refund, Air Canada denied it. This escalated to a civil resolution tribunal, and Air Canada's defense was, let's just say it was creative.
Oh, it was fascinating. They argued that the chatbot was a distinct legal entity and that the airline shouldn't be held responsible for what it said. I mean, really? That's like blaming a rogue calculator for your taxes.
Right? The tribunal rejected that defense, of course, and Air Canada had to pay up. But the case shattered this illusion that AI is some kind of magical, infallible oracle. When it comes to specialized domains like corporate policy, law, or medicine, the failure rates can be shockingly high.
And that's the thing. In some medical reference tasks, hallucination rates have hit nearly 40%. That's not just a glitch, that's a trust crisis. And it highlights the gap between just using AI and actually engineering AI systems that work reliably.
And that's where the discipline comes in. Most of us treat AI like it's a smart colleague, but in reality, it's more like a highly eager, probability-driven math engine. It's not thinking, it's predicting.
That's such an important distinction. And to fix the unreliability, we have to decode how the engine actually works. For example, AI doesn't read words the way we do. It processes language through something called tokenization.
Right? So large language models don't see words as words. They see them as integer tokens. Before your carefully crafted prompt even reaches the neural network, a tokenizer chops it into chunks and assigns numbers, to those chunks.
And this can lead to some hilarious and sometimes embarrassing failures. Like, remember that viral math problem? If you ask an AI which number is larger, 9.11 or 9.9, it might confidently say 9.11 is larger.
Because it's not doing decimal math. To the tokenizer, it sees the integer 9, a decimal point, and the integer 11. Structurally, 11 is larger than 9, so it makes this completely incorrect but logical prediction.
Exactly. Or take the word strawberry. If you ask an AI to count the R's in strawberry, it fails because it doesn't see individual letters. It sees the entire word as a single token. Asking it to count the R's is like asking a human to count individual brushstrokes in a painting just by looking at the file name.
That's such a great analogy, and it begs the question, if the AI is blind to meaning and just guessing the next token, how does it ever get anything right?
It's essentially playing what we call the next token lottery. It calculates a massive probability distribution and picks the most statistically likely token based on its training data. So when you type the capital of France is, it doesn't look up Paris in a database. It just predicts that Paris is the most likely next word.
But if the probabilities are close, it might pick a less likely path, and that's when you get hallucinations. And this next token lottery gets exponentially messier when you overload the AI's context window.
Right, the context window. That's the model's short-term working memory, and it's not some perfectly organized file cabinet. It suffers from a flaw called the lost in the middle effect.
Yeah, this is fascinating. When you stuff a massive document into the prompt, the AI uses an attention mechanism to decide what's important. But this mechanism isn't a perfect scanner. It's more like a mathematical spotlight that shines brightly on the beginning and end of the prompt while blurring out the middle.
So if your core instruction, like always respond in French, is buried on page 25 of a 50-page prompt, the AI might just forget it entirely.
And knowing all this, the only way to get reliable answers is to force the AI to engage in what psychologists call system 2 thinking, deliberative, step-by-step reasoning. But here's the kicker. AI doesn't naturally do this. It doesn't pause to reflect or plan its response. If it's not talking, it's not thinking.
Which is why we, as systems architects, have to engineer that deliberation. The simplest way to start is with few-shot prompting, teaching by example.
Right. Instead of just giving the AI a rule, you show it examples. If you want it to classify customer sentiment, you don't just say, be accurate. You give it 3 examples of how to weigh mixed feedback before asking it to process real data.
And for more complex logic, you level up to chain of thought prompting. You explicitly force the model to list out its steps before arriving at an answer.
And if you're tackling something really high stakes, you move up to tree of thought prompting. This is where the AI explores multiple paths simultaneously, hits dead ends, and backtracks. Kind of like playing chess.
It's a game changer. For example, in the game of 24, where you use 4 numbers and basic math operations to reach 24, standard prompting had a success rate of just 7.3%. But with tree of thought prompting, that jumped to 74%.
That's a staggering leap. But here's the trap most people fall into. The one task, one prompt fallacy. We try to cram everything into one mega prompt, which completely overloads the AI's attention spotlight.
Instead, you have to practice decomposition. Break the workflow down and chain specialized prompts together. One prompt analyzes the error code, another diagnoses it, and a third drafts the response. You isolate the logic.
And this approach doesn't just improve reliability, it also helps you avoid what's called the ambiguity tax. In automated systems, the AI's chattiness can break your code if it adds unnecessary conversational fluff.
Exactly. When integrating AI into software pipelines, you're not having a conversation. You're defining an API contract. And mixing friendly chatter with hard logic opens you up to severe security risks, like prompt injection.
Which brings us to the container principle. You must sandbox user input using strict delimiters, like XML tags, to prevent the AI from treating user data as instructions.
And on the output side, you enforce a no-yapping protocol. But here's the challenge. If you silence the AI to prevent chattiness, you risk killing its ability to reason.
That's where the silent reasoning trick comes in. You design your JSON schema to include a hidden thought process field where the AI can do all its messy reasoning. Your software then discards that field and keeps only the clean final output.
It's such a clever workaround. And once you've built this structured, secure system, you need to test it rigorously with a golden data set, 70% normal queries and 30% edge cases designed to break the model.
And you evaluate performance using structural, semantic, and stylistic metrics. For subjective qualities like tone, you use an LLM as a judge with a strict numerical rubric.
It's all about turning subjective evaluation into hard math. And once you have this testing loop, you can fine-tune your AI engine, optimize hyperparameters, and even cache static rules to save time and money.
Ultimately, this isn't about finding a magic prompt. It's about building autonomous systems. We're moving from crafting individual bricks to engineering entire cathedrals.
And as we do, we have to stay vigilant. Autonomous systems are powerful but dangerous if left unchecked. The human-in-the-loop imperative is non-negotiable for high-stakes actions.
Exactly. So, if there's one takeaway today, it's this. Reliability in AI isn't luck. It's structure, discipline, and rigorous testing. With these principles, you can stop drowning in work slop and start building engines that work for you.
And as AI evolves, we might even see a future where it engineers its own prompts better than we can. But until then, the tools are in your hands. Thanks for joining us on this deep dive.
Thanks for listening to this first episode in our 3-part series. I am JT, and thank you again, Madison. Don't forget, if you are an aspiring entrepreneur looking to start an online business or already have a business you are looking to grow, check out the Startup Venture Lab free community online at startupventurelab.com. Till we meet up again, JT out.
This podcast is brought to you by the Startup Venture Lab. If you're interested in starting an online business, have an idea, or are looking to grow your business, check out our exclusive member community online at startupventurelab.com.